in IEC 61511, the 2016 edition. The interesting thing that we'll find is that they have actually beefed up a lot of the requirements in 61511 now, as we shall see. So I hope you find this informative and interesting. If you have questions, either you can save them to the end or you can sort of send me questions as we go through. But just a bit about me. My name's Steve Gandy. I'm VP Global Business Development for Exeter. At least that's one of the hats that I wear for Exeter. The other part is that I do a lot of the training for the FSC 100, the safety course that we do. My background is safety and controls, nearly 40 years now. I started life as an electronics engineer, doing analog and digital microprocessor-based designs and software, and joined a company called ICS in the UK. It's now part of Rockwell, of course. Back in the 80s, designing ESD and fire and gas and fire detection systems. Eventually I was in charge of the development group that we had called ICS Technology, and we actually started the development of what became the trusted ICS. Also, I've published some papers, mostly in the UK when I was there, and here in the US too, and have, as I say, recently been doing a lot of the teaching. I've been with Exeter now for 5 years. And it's always fun teaching the courses and doing webinars, because you get to meet some interesting people and you get to hear some interesting things. So about Exeter itself, we're a global company. We've been around for nearly 20 years, and we've developed into several divisions that provide software tools. The Excellencia tool, some of you will be very familiar with. The SIL Alarm tool, you might know. The Cyberfax tool and the SILStat tool that we have now, and we've worked mostly with manufacturers and designers, system designers, end users and engineering contractors, and we've been providing products and services around the 3 disciplines of functional safety, cybersecurity and alarm management. We also do a lot of product certification to 61508, and now we're doing IEC 62443 for cybersecurity. And the nice thing about those 3 disciplines, the functional safety, cybersecurity, and alarm management, is that they tend to be industry agnostic. So we can apply them to any industry where this requirement is a mandate. So for example, we've worked in the automation industry, the automotive industry, nuclear, and the process industries. The consulting side of things, we do a lot of process safety consulting around IEC 61511. We also do the 62061 and the 26262. We've worked mostly throughout all the phases of the life cycle, so we can do facilitation for PHAs and LOPAs. We've done SRSs, SIL verification, SIL determination, proof test generation, etc. And on alarm management, we've done a lot of alarm rationalization and also alarm philosophy development for clients. And on the control system cybersecurity side, we do a lot of risk assessments and vulnerability assessments based around the IEC 62443 standard, which is predominantly based around the ISA 99 standard. The engineering tools I mentioned, the Excellencia is a suite. You have the PHA tool, FAX, you've got the LOPA tool, LOPAX, and then the SIL selection, SRS, and Silver tool, as we call it, for doing the SIL verification. We can also do FMEDAs and the SIL alarm and SILStat, which is used for the gathering of the plant information. And now we have a Cyberfax tool to help us do the risk assessments on the cyber side. I mentioned the product certification around the functional safety, the 61508, cybersecurity. We're also accredited by ANSI in North America to do this work, and also for ISA Secure and Achilles. We run a lot of training courses around these disciplines. With the process safety one is around the what we call the FSC, the Functional Safety Engineering 100 course, which is a 4-day course. We also do one-day overview courses, and we do IEC 61508 courses, 26262 courses, the machine safety courses, and also the cybersecurity and alarm management. We've generated a lot of reference materials as well. So we have the SERH, if you're familiar with that, Safe Electrical Reliability Handbook. This has all the failure rates of all the types of equipment you'd expect to find in the process industries, and that is actually built into our Excellencia tool. So the Excellencia tool has two unique features. One is that its Markov model SIL calculation engine has been assessed to SIL 3 independently, and it also has the inbuilt database, which makes it pretty unique in that sense. As far as the rest goes, we have a lot of material through our website. We have our SAEL, which is our Safe Automation Equipment list, which is free. That has a list of all the certified equipment, and you can go in there and have a look under particular device types, and you can look at particular manufacturers. Then you can see under the view details the certificates and the assessment reports. We also hold these webinars, which are free. We do those regularly, and we have a number of white papers published. Also, all the webinars that we've done are archived. So again, if you go to the www.exeter.com website under resources, you'll find these all archived as little YouTube videos that you can watch. They're about an hour. So what we've done is we've established schemes here for the functional safety cybersecurity certification of systems and the products, including the components, as well as personnel. And we'll talk about that in a minute. And the functional safety certification involves a detailed analysis of the engineering processes and design margins. So we're looking at random failures in all failure modes. And from the cybersecurity side as well, we also look at the analysis of the engineering. So how has it been designed? What defense mechanisms do they have? And of course, network robustness, which is very important. The reference materials, these books we've published. In fact, our FSC 100 course is based around this practical SIL target selection book you see here. And I do encourage you to get some of these because they're very useful reference material. When you take the FSC 100 course, we actually provide 3 of these books as part of the course, which is the practical SIL target selection, the control system, safety, evaluation and reliability, and then there's a study guide to help you prepare for the CFSE or CFSP exams. Engineering tools, as I've mentioned, the Excellencia version 4 is the latest one, and that you can either have the complete suite with all of these particular tools, or you can, if you just want the FACS tool for doing HAZOPs, you can purchase that separately, and the LOPA tool, you can purchase that separately. But if you have the suite, then you can do your PHAs in FACS, and you can also identify potential alarms which could be pulled out and put into our SIL alarm tool to create the master alarm database. Once you've done FACS, if you've identified any candidates for LOPA, they can be exported into the LOPA tool, and there you can do the layer protection analysis because we have the database built into the tool. Once you've done that, you can do your SIL selection, whether qualitatively using risk matrix or risk graph, or quantitatively using the tolerable frequencies, and generate the SRS and do the SIL verification. So you can actually do the design inside Excellencia, do the SIL verification, and then create a detailed design SRS. We also have a proof test generator which will generate proof tests for the CIFs based upon the equipment selection, and then a lifecycle cost analysis tool if you need it. The SILstat tool provides us with the ability to run our proof tests. So again, if you've done your design in Excellencia, you can export it into SILstat, and you'll get all the equipment, the details for each CIF, plus the proof test, which you can then run on a Surface Pro, for example, recording all the information directly into the database. So it cuts down time and increases efficiency. And like I said, the CyberFACS tool is similar to the FACS tool, but instead of doing safety, we're doing cyber risk assessments. Okay, so personnel competency. There's an interesting quote from Chuck Miller, Emerson Process Management, where he takes the acronym for the Safety Instrumented System, SIS, and he says now, basically, safety is serious. I like that. I think that's very, very true. Safety is serious, and of course competency is required. So why is competency so important? The HSC did a study of accidents involving control systems, and they performed it in 1995, and then they did it again in 2003. And what you'll see here is that we actually have over 50% due to bad specification and design and implementation as being the root cause of these control system accidents. So why is that? Well, this is what we call systematic. This is a problem. Now, both 1508 and 1511 have been designed around a safety life cycle. And the idea is that we're trying to build safer systems that don't have some of the problems of the past with some of the prescriptive standards, because these standards, the IEC 61508 and 61511, are performance-based standards. So in other words, they say this is what you need to do, but they don't tell you how to do it. With a prescriptive standard, for example, they will say this is what you need to do and this is how you do it. So for example, in the NFPA 85, it says double block and bleed that you need on the fuel. The purpose is to try and build cost-effective designs that match our risk. So you can utilize technology to take advantage and be able to design more cost-effective systems. We also get rid of weak link designs that cost a lot and provide very little. Before 1508, there was the DIN VDE 0801 in Europe, and they had a class 3 classification that if there was any risk of serious injury or fatality, then you had to design with 3 sensors on the front, voted 2 out of 3. You had to use what was known as an AK6 PLC, which was basically a safety PLC, such as a Tricon. And then you'd have a single solenoid and a single valve. Well, of course, where's the weak link in all of that? It's at the back end, single solenoid, single valve. So that, for example, that was prescriptive. You had to do that. But it ultimately led you to have a weak design that was expensive. So the purpose of this is to actually get rid of systematic faults. Try and avoid systematic faults. And then we also want to reduce the potential for random faults. So the purpose of the safety life cycle is to try and achieve these two things. So we're very interested in being able to prevent that. And that's the purpose. And from the point of view of competency, competency feeds into the systematic side of things. And this is the change. I've given you the extract here from the actual standard itself, the 2016 standard, and you can see this is the red line version where you can see what the changes are. And as you'll see here, this has been beefed up because now it's saying shall be addressed. So it's saying the following items shall be addressed. And here we're looking at engineering knowledge, training and experience appropriate to the process and applications. And then you're looking at the knowledge, training and experience appropriate. Here again, knowledge of the legal and regulatory functional safety requirements. That's another one. So that's basically saying you need to know and understand what 1508 and 1511 is all about if you're in the process industry, for example. You've got to have adequate management and leadership skills appropriate to the role in the SIS safety lifecycle activities. So here again, roles, responsibilities are coming up. Then this new clause, 5.2.2.3, where it's defining that a procedure shall be in place to manage the competence of all those involved in the safety lifecycle activities, and also periodic assessments need to be carried out to document and for the competency against the activities being performed. So here it's very clear. You've got to not only have somebody responsible but competent, and you have to record the competency. And you've obviously got to carry out regular assessments of that competency. Here it says periodic assessments. Because it's a performance-based standard, it's not telling you how often you need to do that, but you need to have a procedure and a policy that you can point to say, yeah, this is what we do. So it's very important, and that's why that's been put in there. So again, what we're trying to do is we're trying to minimize potential systematic issues. And this is where we talk about the 3 Ps as it comes down to systematic. And this is personnel. The personnel have to be properly trained and competent, and this statement reinforces that. Then procedures have to be correct and be followed. Oftentimes there are procedures, but there's examples where, if you look at the BP Texas City example where the ISOM unit blew up, it was because during startup the operators routinely violated their own procedures. So if the procedures are not correct or not being followed, that's another potential systematic issue. And then the paperwork. Got to have documented traceability of your competency, the testing and assessing. So all of that has to be in place. So this has really been beefed up. And the reason it's been beefed up is because there's still issues around systematic. The other thing you need to remember is that the IEC 61511 standard has not been written by academics. It's been written by end users for end users. So what about competency requirements? We in Exeter have our own system, and here's an example of it for you to look at. So what we're saying is if anyone's involved in hazard identification, where we're facilitating or leading a HAZOP, they have to hold at least a CFSP or CFSE, and they need to have read and understood the sections of the process hazards analysis, have read and understood relevant Exeter training, textbook and best practice material, and have read and understood at least one detailed hazard identification report. And then it goes on to talk about the typical allowed basic tasks and the senior requirements, as you can see. Here's another example for SIL selection workshop leadership without LOPA, and this is one with LOPA, and you can see what the basic requirements are, what the typical allowed requirements are, senior requirements, etc. So this is an example of how you could do this. Another example. We use this as part of our FSM, our functional safety management, because we have to conform to the requirements of ANSI as part of our certification, and we get audited twice a year, so we need to include our own functional safety management process. If you are a COMA site in the UK, then you obviously need to be following RAGAGAP, recognized and generally good engineering practice or best practice, and that would mean that you should have some form of functional safety management program in place where you've defined roles and responsibilities and you're monitoring and tracking competency. So this is where we're showing CFSP or CFSE, and here for senior requirements you need to have at least a CFSE. So just to recap on the certification or certificate, certification is an ongoing process and results from an individual's knowledge, skills and competency, as opposed to a certificate which results from an educational process. For example, when we run the FSC 100 course, as part of the course there's a 1-hour exam which is based upon just the course material. If you pass that, you become a functional safety practitioner and you get a certificate. That's different from the CFSE or CFSP, because with the CFSE, for example, you have to show your knowledge and competency as well as you've got to sit an exam. And the exam is not based necessarily on a course. It's based upon the standard, and it's based upon practical knowledge and experience. And you also have to submit a separate case study. So the requirements are pretty arduous. The other difference between a certification course versus a certificate is the certification has to adhere to ISO 17024, which basically separates church from state. It basically means that whoever teaches the course has to be independent from whoever's setting the standard for the exams and marking the exams. So you have to have a measure of independence. And this is what this means here against a set of defensible standards. So the exam is set up by the CFSE board, it's administered and monitored by the CFSE board, and it's marked by the CFSE board. So even though I teach the course, I have no idea what's going to be in the exams. I do not get involved in marking the exams, and I have no idea how my students get on unless they tell me. So if we look at some of the programs that are around at the moment, you've got ISA, you've got the TUV courses, and of course these are basically certificate programs, and this is a certification. We've introduced the CFSE, CFSP, or the CACE, which is the Cyber Automation Controls Expert. So that's the equivalent of a CFSE, but from a cyber perspective. So if we look at the requirements now in 15.11, the 2016 version, they do match up nicely with the programs that we have in place. So at the lower level here, we have certificate programs, which is Exeter's FSP, Functional Safety Professional, and then TUV has a FS Expert, and then ISA has an ISA 84 Expert. And of course, the CFSP and the CFSE is part of the certification program, and this is where the 1704 comes in. And of course, the CFSE in this case represents the gold standard in competency demonstration. So there's a question. Let's have a look. Uh-oh, sound's gone. Hopefully my sound is okay. Let's see. Okay, you've lost sound.
I can still hear Steve.
Okay. Yep. Okay. Yeah, looks like some of you were having a little bit of sound trouble. Others managed to hear me okay. Okay. So in terms of where do you fit in, you can look at it this way. The certificate programs allow you to take the FSP, which is the Functional Safety Practitioner, that's included in our FSC 100 course. There's an ACS for an automation cybersecurity, which would be included in our cybersecurity course, and then you can be a fire and gas practitioner included in the fire and gas course. The ISA has a CIS expert, certificate expert, TUV Rhineland has the FS expert, and TUV Sud does functional safety expert. So step 2 then would be the certification program. So depending on what you want to do, you could do the CFSE, Certified Functional Safety Expert, or the Certified Functional Safety Professional. And the CFSE is designed for senior people who have significant life cycle responsibilities and would be really doing SIL verification, SIL determination, and PHA or LOPA work. The CFSP is designed for either early entrants or for managers who may be responsible for managing CFSEs, for example, but are not actually going to have any significant involvement in some of the life cycle work, but they need to have, obviously be competent to manage the people and understand. And the same thing from the cyber side of things. There's the Certified Automation Cyber Expert, Cybersecurity Expert, which is equivalent to the CFSE, and then the CACS for the lower entry. So the advantages here are that obviously it provides some proof of competency. It does actually increase your value as an employee, and it does differentiate you from your competitors if you're going for different jobs. If you're interested in becoming a CFSE or CFSP or a CAC or a CACS, then obviously you can prepare for the certification examinations. And like I said, it's not once and done with these certification courses. You have to renew every 3 years your certification, and you've got to prove that you've been maintaining some level of standard. You don't need to set the exam again, but you need to submit something to the CFSE board to support your ongoing certification. And it helps provide analysis of where candidate strengths and weaknesses lie, and also allows you to insert Exeter FSP, for example, after your signature. For a CFSE and CFSP, same sort of thing, and now you can add CFSP or CFSE after your name, and it does indicate some sort of mastery or competence as measured against a defensible set of standards. And this is this approach that's taken with the 17024. And then you're looked upon as a mentor or leader in industry. So these all add to the competency side of things. And you can take different types of exams. There's the automotive safety applications, there's machine safety, process safety, then you've got the 1508 hardware and software development, and then the certified automation cybersecurity. So all of these are available to be taken. And you can find out more about this from the CFSC board, which is the www.cfsc.org is the website. So just to summarize, 1511 in the 2016 version has a lot more emphasis on competency for personnel and contractors. And the reason being is that we're still seeing issues surrounding competency. I mean, we see it too, because we get called in to do SIL verification work, and we will look at the LOPA and the PHAs, and we often find problems. And again, with the PHAs, which is the start, the idea is that when you do a PHA, you're supposed to have your most senior and most experienced people in the PHA. Well, of course, tying up your most senior and experienced people for a week or more is, in some cases, is very difficult for certain companies, and they can't do it. So they might spare one person and then they'll supplement it with some junior people. The problem is the junior people don't have the knowledge. And you do need knowledge from certain disciplines, such as obviously the process side of things. You need it from operations and maintenance side and engineering. And the thing is, if you don't have the expertise, then you're really depending on the facilitator to understand and know and steer them in the right direction. And this is where we see some of the problems, because unfortunately PHAs tend to be treated a bit like commodities now. So experience and capability often gives way to price. And there are a lot of smaller one-man band outfits that will say they can do PHA facilitation, and some of them can. Don't get me wrong, I'm not saying they can't, they can, but there are several that don't, and we see it too. And what happens is if you get it wrong at the PHA phase, then you could miss certain scenarios, you could miss particular consequences. Then if you don't do the LOPA correctly as well, and here's another area we find problems with, then you could end up with either not enough SIFs or too many SIFs designed or defined with high levels of integrity, which they don't need, or worse still, not enough. And I'll give you two examples where we're working with two clients at the moment. One client, when we got involved, they had done their PHA and LOPA, they'd identified 94 SIFs with mostly SIL 1 and SIL 2s, but with quite a few SIL 3s. When we went back and did a review for them, we got it down to 54 SIFs and no SIL 3s. There's another client we're working with, started off with 169 SIFs, whole bunch of SIL 3s they didn't need, and in fact what we've got it down to was that they only actually needed 46 SIFs and no SIL 3s, and then they needed some interlocks. So again, if you get it wrong at that stage, it's going to cost you potentially further down the line. So I always urge people that this competency issue is very important, and you've got to make sure that people who say they can do these things can prove that they can do these things. And then if you don't, what you'll end up doing, as I've said, is you'll introduce these problems, which of course are systematic. And so the whole point here, and why the committees put this emphasis on competency, is to help reduce systematic faults. And that's the primary driver for this. So there's obviously more rigorous requirements for end users as well as the contractors. So if you're bringing in third parties, they've got to be competent. They've got to show they're maintaining competency. They've got to prove that. And that's now covered in 61511. Periodic assessments of personnel is now required. So if you're looking at your operations and maintenance side of things, you're your operators and your maintenance guys, especially the maintenance guys, if they're looking after SISs and CIFs, they need to know what they're doing. So obviously they need to be assessed regularly. And regularly, it's entirely up to you as the end user to decide how often you want to do that and how you're going to do that. Whether you put them on a training course, whether you have some internal simulators that you can put them on, whatever it is you decide to do. But you have to do that and you have to document it. So this is the point. Okay, so thanks for your time. If there are questions, I'm happy to take questions. Anybody have any questions? No, don't see any questions. There's one, how do you prove competency? Well, you know, it's an interesting one because you can do it one of several ways. You see, you can obviously go through a course and have either do one of the certification courses that we offer or one of the other courses. So that's part of proving it. Obviously, the CFSE is quite a tough challenge because the pass rate is only 65%. That goes a long way to proving competency. Here again, it's a question of experience, capability, and qualification. So if you're showing that you're qualified, and part of that with the CFSE is you have to submit a case study to show where you've worked on a safety project, and you can prove that you knew what you were doing. That goes a long way. Yeah, that's true. Somebody is saying the best way to record ongoing competence is similar to CN's requirements. You could do it that way too, but like I said, with the certification, it's not a once and done. You're permanently proving that you're maintaining your capability. So that's why I would encourage you to consider doing either the CFSE or the CFSP, because every 3 years you need to do that. How would you envisage the competent authorities, for example, the HSE, policing the requirements for competency? Well, here again, it's the HSE. We've actually been talking to the HSE, funnily enough, because this is something we've been discussing with them, at least one of the issues. And here again, it's if you get regularly audited, that's something they're now going to want to see. But of course, a lot of people tell me, well, we've never had any problems. And the same here in the US. OSHA, if OSHA doesn't audit you and you're sailing under the radar, you can do that for so long until you have an incident. Once you have an incident, then you will be under the microscope. And if they can see that you haven't proven or haven't been following a competency program and you can't show where your people are competent, then of course that's when the fines start. And it's the same old thing. Once you have an incident, then you're on the radar. And in fact, we're dealing with one customer at the moment, and they're on OSHA's radar. So they're having to do all sorts of things, and we're helping them with that. Any other questions? But these are good. Somebody said to me as well as how do we do regular assessments? Well, again, you'd need to think about, from your operator's point of view, it's probably easier because a lot of the logic solver people, and certainly the BPCS or the controls people, provide simulators. So you can work offline on a simulator using the same application that's running in the main control room for the operators, and then you can have somebody go in there and throw them a few curveballs, as they say, to see how they respond. But you would have to, that would be part of your program. And third parties such as us can help with developing programs to put in place where you can measure competency according to requirements. See, here again, if we look at the maintenance side of things, and another reason why competency is in there as well is if you looked at that HSE, at the back end during maintenance, there were about 20 or 35% if you look at the maintenance errors and the commissioning errors that appear at the back end. And I say this when I teach the course. If you look at the safety life cycle, a lot of emphasis on the analysis phase and through the design and implementation phase until you get to operation and maintenance, which is one box called clause 16. Well, of course, if you like me, if you're old enough to remember the adage of 20-20-20, you know, 20 weeks in design, 20 months in operation, 20 months in implementation and 20 years in operation, then you're going to be spending most of your time in clause 16. And therefore, if your maintenance people don't understand what the SIS and its SIFs are protecting against, and don't understand from each particular SIF, what are the startup sequences, what are the overrides and bypasses, what are the interlocks, what is the SIL level, what is the proof test interval, what proof test procedures do I need to be familiar with and to run? Do I record the as found and as left conditions? All of these things have to be followed. And clause 16 is very specific about needing procedures in place and having your people trained before you start up. So that's all part and parcel of competency. Do they understand the equipment they're using? Do they know how to calibrate the equipment? Do they know how to conduct repairs? Do they understand the difference between a SIL-rated device and a non-SIL-rated device, and the importance of making sure that when they replace equipment in safety instrumented functions, that they replace like for like? And if it's a pressure transmitter, they just don't go to the stores and pull out a non-certified pressure transmitter. Are the training courses enough to meet competency requirements? Would you suggest for technicians and operators, is that classed as a regular assessment, or would you recommend similar to engineer, providing that you have worked within the parameters and functions, say proof testing, etc.? Let me see here. The training courses themselves do prove some competency if you pass, but obviously you've got to have some practical assessments figured out. So again, what you might do is you may go and observe what your maintenance guys are doing when they're doing a routine calibration check, and also running when they're executing proof tests and making sure, because the other thing about the proof test is it's not just an electrical or mechanical test, it's also a visual inspection. And also, a lot of people get confused with proof testing because they assume proof testing is to prove that the SIF works. That's not the intent of the proof test. The intent of the proof test, per the standard, is to design a test that can find potentially dangerous faults that any automatic diagnostics cannot find. That's the whole point. So you would make sure that your maintenance people could do that, could run the proof test effectively, that do the visual inspection for looking for either loose wires or corrosion, etc., or unauthorized mods. That can also happen. Anything else? Well, if you do think of any other questions, my email's here at the bottom. You can always drop me a line, and we will make the slides available, and the webinar is being recorded right now, so that will be available too as a YouTube. Please let me know if you have other questions, and we're obviously here to help, as they say, so either contact myself or Ali in the UK office. She'll be happy to help too. So if there are no more questions, I thank you for your time. I hope you found it interesting and informative, and please let us know if there's anything else we can help you with. Bye for now.